Hi everyone, just wanted to take a minute to talk a little bit about transformations of exponential functions, which is section 6.5 in our book. And ultimately, what we're going to be doing with this is going to be very similar to what we have been doing in terms of transformations, right? You're going to have a vertical transformation and a horizontal one. And this one should be relatively straightforward now that we've done it a couple times, but it's good to make sure to go over it a little bit more. So as a little reminder, who recalls what h and k did when we had an absolute value function? So h and k in an absolute value function were simply just kind of representing the horizontal for h and the vertical for k transformations or the translations, right? So the h was determining left and right, and the k was going up and down, okay? So they were the vertical and the horizontal. They also represented the vertex, right? Which is kind of the sum of the shifts, right? We started at 0, 0, we went over 2 and then up 5. The vertex now becomes, 2, 5. The thing that you just need to be careful of, that was x minus h, meant you went to the right. If you had a plus 2, you went to the left, all right? But k, if you had plus, you went up, minus, you went down, all right? So that's just a quick overview on what h and k were. And we are going to continue on using h and k with these. All right. So let me clear that. Our objectives for the day are going to be to describe horizontal and vertical transformations of exponential functions. And we're going to explain how exponential functions affect their features, the transformations. Okay. So a couple pieces of information. Obviously, transformation is simply just any sort of change to your original function. So our original function is going to be this. This is our parent function. Again, we use 2 because if we did 1, it would just be a line. Because 1 raised to any power is still 1. So a transformation is going to be, we're going to like stretch it or compress it or translate it. So slide it left or right, up or down, things like that. That's all it is. Horizontal translation, that's going to be your slide left, right. And in general, we are going to refer to this as h. And then our vertical translation, that's going to be our slide up / down. And this is going to be our k, right? We're going up and down. Okay. So, just as a point of reference, what do you think the value of k is going to do? Well, based on what we would have looked at slightly earlier with our other functions, you can probably guess that k is going to cause it to go up and down, right? It's going to be a vertical translation. So we're going to go up or we're going to go down. And that's all it's going to do. Okay, that literally will be what it does. Oops, sorry, I hit the wrong button. Okay, so let's take a little bit more of a look at that. So let's look at what it does. So when we add 3 to 2x, see how we started, right? We started over here, 0, 1 was my y-intercept. Now I go up to 4, right? I've just added 3. Essentially what you can see here is I'm just taking all of my coordinates and I am adding 3 to them. That's all I'm doing, okay? I'm just adding 3. So now my y-intercept is 4. What do you think that means about other pieces of information? Well, everything is going to shift up 3, okay? So the domain, that was always infinity, infinity, negative infinity to infinity. That was all real numbers every time anyway. So that doesn't change. However, my range is now never going to go below 3, right? Because I knew before it was never going below 0, but now I just added 3 to everything. So it's never going to go below 3. That makes my asymptote now the horizontal line at 3. Okay, so that has changed. Every other property has not changed, but the asymptote and therefore the range have changed, which is also affecting your intercept. Okay. Now, what would happen if it's negative? as you would imagine, it is going to shift down. This is how you actually would get something that crosses the x-axis. Because we essentially, when we are doing this and subtracting 3, right, minus 3, minus 3, minus 3, minus 3, minus 3, we are now going below the x-axis. That's okay, right? I know in the past I said it's not going to cross. That was before we started translating it. So now we have shifted it down by doing minus 3. And now my asymptote is going to be at 0 minus 3, which would be negative 3, right? So now my asymptote is at negative 3. My y-intercept has shifted down from 1 to negative 2. And then everything else is going to end up being the same. Again, it does affect your range. You do need to be careful. Your range is now anything bigger than negative 3 as opposed to 0. The domain will not change. Okay. So, I love a good slider. So I'm going to share this in the video so that way you can play around the slider if you would like, make some observations. But ultimately, you can kind of explore what happens when it goes up and down. All right. So let's talk a little bit about this. How does the graph of g of x equals 2x plus 1 compare to the graph of 2x? Well, straightforward enough. We know it is going to shift up 1. So now my y-intercept is going to be 0, 2. My range is going to be bigger than 1. Okay, or you could write it as this, 1 to infinity for domain. That's pretty much the only thing that's going to be different. It's going to have, still going to have the same basic, kind of curved shape. All that information is still going to stay the same. The only difference is that now it is shifted up by 1. So what about if I subtracted 1? Same idea. Okay, it is now going to just shift down. The thing you have to be careful about is your original y-intercept is 0, 1. So when you go down 1, it's now actually at 0, 0. That's kind of weird, but that's what it ends up being. Okay. Now, if the function is 1.4 times 2.45 to the x, and it's translated down 25 over 4 units, write the equation of the new function. Well, if it's translated down, that means I subtract it on the outside, right? So it'll be 1.4, I'll call it g. Minus 25 over 4. That's all. That's all I'm looking for. You can just take it, move down. Okay. Now, as we talked about, this does affect other things. The domain, as we said, that'll stay the same. It's still all real numbers. So it's still going to be negative infinity to infinity. Okay. The range has a difference. It's going to end up being k, whatever your k value is, to infinity. So if it's negative 2, you'd put negative 2 there. If it's 13, you'd put 13 there. Okay? The y-intercept is going to end up being 0, 1 plus k. So if you had negative 2 as your k, it would be 1 minus 2. All right? So your intercept, remember, it starts at 1, and then you're either going up, let's say 13 from that, or you're going down to whatever. The asymptote is going to follow kind of the same idea. It's going to end up being y equals k, right? So whatever your value of k is, here's your asymptote. That's the line it's not going over. So if it's plus 7, the asymptote is 7. If it's minus 4, the asymptote is negative 4. Okay, it is always going to be a horizontal line. That is going to be the new line you will not cross. Okay. And if you look more closely at an example, right, you can see here j has gone down 1. So you do have to compare and figure out all the information from there, right? It has gone down 1, so the y-intercept is now 0. My asymptote is now -1. Everything else, still the same. The range, now from -1 up. Okay. Right, so if we were to look at this, how does this compare? Well, they're going to have the same basic shape. This one's just going to have an asymptote of 4 and have a range of greater than 4 and have a y-intercept of 5. This one, you're going down 3. You're going to have an asymptote of -3. You're going to have a y-intercept of 1 minus 3, which is -2. And you're going to have a range of -3 to infinity. Okay? So that is ultimately going to be how they compare. And if you were to look at it as the graph, you would essentially have something like this, right? Here's my original. The -3 would be like down here. The +4 would be, up here. Okay. Simple enough. All right. So let's take a look now at what happens when you put that h involved. So as you could probably guess, when you have an h there, this is going to be a horizontal translation. Okay. So to be careful, when I have x minus 1, that means I go to the right 1. Right? So that still applies. Okay? That still applies. I cannot stress that enough. So that would mean if I had like a -1, a +1, right there, it would be left 1. So you need to be careful about that. It's going to be a horizontal. It's going to go left and right. You'll notice it is up inside the exponent. It's not inside the parentheses. It's in the exponent. That's where it's going to go for this function. Okay? If you take a look, now this one's a little bit harder to work with just because of the visual. I will say it is kind of relatively well easily seen. All right, so if here's your 2x, right, and I do -5, it's going to go to the right 5. So essentially, I took that y-intercept and I went boop over 5. Okay, so that's how you could kind of figure it out. If I'm starting at 0, now the point 0, 1 has become h1. Okay, so 5, 1 has become kind of essentially what has happened. You could find the intercept, but it's going to be essentially whatever -5 was, right? So essentially, what did we do here? We took our y-intercept and we went over here, and we just moved it over however many it said in the exponent. So in this case, to the right 5. Okay. So if it's less than 0, right, we're going to pull it to the left. So as you can see here, I have a -3, which makes it look positive, right? So I took my point right here and I went boop right over here. Going that way. To the left. So now what used to be 0, 1, I've taken it, I've moved it over, so now it's -3, 1. Okay, so that's my point, -3, 1. That's all I'm doing with these. I'm just taking my original function, I'm just sliding it over, and the most easily identifiable point is your what was your original y-intercept, right? So if your original y-intercept was 0, 13, I move it over 3, now it would have been -3, 13. Okay. So again, I will put in the video in the comments this to explore if you would like to kind of play around with the sliders. So let's try it. Let's compare it. So when you see this, we go up here +2. So that means I'm going to the left 2, which essentially means what was 1, 0, 0, 1 has become -2, 1. I just took it and I went whoop, over here. Now I have a minus, so this is going to be right 2. So that means my 0, 1 has now shifted over to 2, 1. All right. Now, one of the important things to consider when we're looking at this is kind of to compare the different graphs. It can be a little bit hard to identify sometimes, but my recommendation to you is kind of look for what's going on. So we have X, F, and Q, and then we have F and P. So let's compare. F is represented as 4 to the X. A scientist observed the number of bacteria in 2 other colonies, P and Q. The graphs for each of these colonies represented by are both translations of F. Compare P and Q. Okay. So first of all, let's just take a minute and look at this. And we know when we were looking at the vertical, I could just like add 3, right? And I would just get like, 1/16, 3 and 1/16. 1/4, 3 and 1/4. So this is clearly not going to be a vertical translation. Similarly here, if I look at my graph, P is also not a vertical translation. However, you can see I almost have this kind of like cascading effect going on here. So whenever you see that kind of like a cascading effect, right? I have the 1, 1, 4, 4, 16, 16, 1/4, 1/4. That means it's going to be a translation. Depending on which way it has gone will determine whether or not it goes left or right. So let's think of it this way. I know I have 0, 1 as my original 0, 1, right? So what does 1 become now for f of x? Okay, so I want to look for where y is 1, right? So here it is. So my q of x has become negative 1, 1. Okay, so that means I have gone to the left of 1. That would make my q of x this function. Remember, when you go to the left, it's plus 1. Now, for p, what is happening here? I have 1, and here I have 1, 1. Okay, so that means p of x is going to end up being 1, 1. So that means p of x, it's gone to the right 1, so it would be 4 to the x minus 1. All right, so now from there, you kind of have a bigger picture. So when you're looking at this cascading effect, if you end up with like the 1 above, you're going to go to the left. If you end up with the 1 below, you're going to go to the right. Okay. Now, finally, one last time, let's compare the characteristics. Interestingly enough, when you are shifting left and right, the only thing it's really affecting is going to be your y-intercept. Nothing else is going to change. Your domain, not going to change. Your range, not going to change. Your asymptote, not going to change. That pretty much covered everything except for the y-intercept. The y-intercept will change, and that's just essentially because we've shifted it over. It's almost more important to know where the 1 is, though, than it is for you to know anything else. So how does this compare? We took this graph and we went to the right 1. All right. So ultimately, what you're going to be doing is I would like you to, after finishing this video, fill out the exit ticket. And then begin working on the questions on Savas. All right, let me know if you have any questions, and have a great day.